So that should be the question. Of course, the man jump or the man jump vertically upwards. Figure 2 shows the man in 2 positions. The left, it is at the about to jump, right? And then the second one, you see that actually he's off the ground. Yeah. Then very typically, the next question in A, right? You ask you to draw and label the forces, right? Yeah. So you need to label the diagram on the left and the right. On the right. Okay. So okay. How many forces are acting on the position on the left? 2. Okay. So they say we are using free body diagram that you learned in Sec 2 or Sec 1, right? Okay, I'm not sure how is it. Okay, we say that the free body diagram will be like this, right? Of course, it's a weight acting from, we call it weight, right? And the normal reaction. Yeah, my hand is not very stable. Okay, so it's a normal reaction. Yeah, you need to label. You know, I read the Marcus report from the Cambridge examiner. He said some of the students missed out the labeling. Do you think they give you full mark? 1 mark and then not full mark, meaning now half, is 0. Yeah. You write normal reaction because you need to label the name.
Can I write F normal, like at the side bracket normal reaction?
Can. Yeah. Or you need to label the name, not label the symbol. Right? If I put W, right, then I do not know what's W, right? Right? You as an examiner. Correct? So this is how the skill of answering 12 basic questions. Sorry? Name. Right? The question says name the forces. Right? So of course, you can use your free body diagram like that as what you learn in Sec 2. Then, of course, you need to label on that man, the diagram, meaning you have to do this. Right now, this will be the weight. For example, you use ruler and pencil. Okay? Oh, sorry, this is the previous. Okay. Then weight, label it properly. Like that. I don't know why there is a line always like that. Then normal reaction is from the foot or the feet. Right? Yeah, then you say normal reaction like that. Oh, I'm sorry, I need to off my yeah, I'm going off. Okay, wait. I toggle first because I have my WhatsApp on. Yeah, I off my WhatsApp first. Okay. Yeah, sorry. Hey, okay, this is the one. Okay, no. Okay, back here. Keep. Because I think just now I want to off the presentation. Okay, next. Okay, so you label this is weight and this is normal reaction. How about this one? Weight only, right? This is off the ground. Is there any contact? No, right? Too bad. Just so you cannot see my my body language. Is there any friction? Okay. Anybody want to take this what's your name again? This question. He touched the wall. He said, do you? Yeah. Okay. I mean, he has his point, but is it significant or not? Yeah, he's talking about actually on the man that I think maybe this position that he haven't touched. Yeah, he hasn't touched. Okay, just off the man like that. You see not? Like that. Teacher behind. Like that. There. I can jump also. So this one will give you 1 mark. This one will give you 1 mark. Yeah, because in TYS review, I will tell you how you get the marks. Okay. Next one. Okay, we go on. So I give you this blank unless you want to draw something. How about the average resultant force? Okay. What law are we going to use?
Second law.
First law, second law? Second law, right? Then, if Newton's second law, what is the usual so-called strategy that we use? Formula? Yes. So the strategy is formula, so F equal to ma. Okay. So Jiang, you follow so far, right? All right. Yes. What is this? We quickly go into problem solving mode. What is this? Mass, right? M. Then, but I don't have acceleration. Too bad. You'll find the acceleration. What is the formula for acceleration? Okay, this is familiar. So v minus u divided by t. So equal to, where is the my v, where is my u? Am I able to find?
Yeah. 1.5.
Getting like that already, getting. Are you able to find? What is the u and v? Wow. Here is this. You know why not? Because it's the v. How do you get 0? Where? Where is the at rest? The, I think the previous question say that it's at rest, right? Yeah, I thought I saw it at rest. Yeah. Okay, so u equal to, so this is 1.5 minus 0 divided by times 0.50. Now, do you notice the SF in the question? How many SF? Remember, you're going to remember this. Okay. The 0 usually, in Cambridge, I don't think they present as 0.00 because I don't know, right? No. 0, I think you no need. No need. I never see them present into SF. So M is 60, like that. 1.5 minus 0 divided by 0.50. Yes, 180 Newton. Okay. Who did not get 180 Newton in your as a homework? Oh, too easy. Yeah. So we move on to that. The question is leading us to calculate another value, for example. Right? For example, let's read the part 2. Of course, this is my presentation that where I will upload the entire so-called the PDF format into our website. Yeah. Okay? Yes. Left side got what? Friction. Friction. So can you define what is friction first? Mm-hmm. So there is a motion in it. But there is another condition for friction to happen. Not only contact, there is a contact, yes. What is the one that, what is the another condition that you, is it normal or is it sliding? Is it sliding or is it normal? Normal, not sliding, right? So you rule out normal, no friction now. Got it now? Yeah. Because the condition for friction doesn't apply. He's jumping up normally. He's not sliding on the wall, whatever, right? Or sliding on the floor. Am I right? Yeah, next. Let's go to part 2. Okay? The question reads this way, right? The man lands and rests with both feet on the ground. The area of contact is 500 cm square. I want you to pay attention to the unit. Then, the area, yeah, the gravitational field strength G equal to 10 Newton per kg. Then how about, they say determine the pressure. Then, what is this unit? What is this unit? I lost. Okay. What is this unit? Cm square. Is this, which one is SI unit? Which one is non-SI unit? You follow me? Do you follow me? This one is Newton per meter square. This one is cm square. They are not of the same unit. Right now? Yes. So for this question, there is a catch. Do you realize there's a catch? Who didn't realize there's a catch and you get caught? Okay, I got something. Alright. Okay, so you need to convert this to meter square. Are you at your like fingertips when you are converting cm square to meter square? Wow, I got different strategy. Like whose strategy is the fastest? Multiply by what? Multiply by 1000. Okay, yeah. My strategy is that because 1 cm right square equal to 1 cm multiplied by 1 cm, correct or not? Wait, sorry lah, 1 cm, right or not? Then equal to because accidentally click okay equal to cannot click lah, I keep clicking, equal to 0.01 cm, right? Meter, right? Yeah. Then you got how many zero? 3 lah. Right? Yeah, for the meter square. Correct, huh? Yeah. So you convert this first, of course. My next time will show you the answer, correct? Yeah. Then weight 600 Newton. Then you 500 cm square, you get 0.05 meter square. See whether you can get it working right. Shortcut a bit. Yeah. Then only then you can get your 12,000 Pascal or 12,000 meter Newton per meter. Yes. I think there will be a minority of us will have this problem here. So yeah. May I know who did not get this 0.05 meter square? Yeah, so minority 30, 20 to 30% is not minority. Okay, if it's 1% is minority. Okay, so you've got to back up on this. Okay. Yeah. Yeah. So we are coming to the last question already. Pressure. Okay, this pressure is about the left stationary. Okay, meaning like that, normal pressure. Why you take only 600? Why you don't take 180? Yeah, there are two numbers, right? Yeah, why you take 600? I want to ask. See if anybody take 180. Okay, Yota is explaining. Yota, you want to explain to the whole class? Huh? Yes, you are explaining to who are Angel. Okay? Any question on that? Oh, my question you haven't answered what? 600 Newton. Why you're paying why 600 Newton, not 180 Newton? Because you use the weight, right? The weight is the when you are in sec 1, you learn that actually the normal reaction force is equal to the weight. That's it, when you're standing still. Okay, like I think she's frowning. You get it or not? I got to pick that up. Do you get it? Okay, this like that. Okay, this is your weight mg, and then there's the normal reaction force, right? Both will be equal because it's 600, and this is 600 Newton also, right? Yeah. So the pressure on the ground is also equal to 600 by Newton's third law, right? Not on the ground, right? This is ground. The ground also will have a 600 Newton, right? But same contact area. So 600 divided by the contact area, you get the pressure. All right, huh? Okay. I move on to the next one. The pressure exerted on the ground is larger when yeah. Part 3 is a new question. Now pressure was 12,000 newtons Pascal. What this question is asking is what? At which position that is talking about? Can someone tell me? Yeah, I need a webcam next time for Sasha to see the demonstration. Who can tell me how to interpret that you can interpret this question? The pressure exerted on the floor during the first 0.50 second of the jump is larger than the value calculated in part 2. Explain why. going to jump, right? Okay, come. Can you can. Otherwise, I will ask the PE teacher. Yeah, PE teacher, yeah, that's why I call you here. How? Squat. Yeah. And then jump a bit. Why you consider energy? So when before thank you. Before during the jump, the lifting up, right? That's before even the leg leave the ground, right? That's 0.50 seconds talking about. The question only tell you that it's larger. They tell you larger already so that you just focus on your mind to explain rather than think it's larger or smaller. Why larger? Which one? Which one you want to say? What? Extra force exerted, of course you are on the right track. But how to say guess? How to guess that extra force is correct without substantiating the guess with numbers or even the theory behind? I don't buy you because this is pure physics. I need a bit more concrete. Okay, 1% at a time. The thrust must be more than the. Okay, iota is on the right track. The thrust. Why the thrust must be greater than the weight? Is it? Wait. He can move up. Did the question say he just move up? What is the physics term? Yes, the physics term is actually he accelerated, right? In part one, right? In part one, what did you calculate? Go back to your. So Xiang, you also refer to your part one. What did you calculate? Yeah. You see, he's accelerate, but he need to accelerate first. He need to accelerate. Yes, I think you are right. Since see that the moment he left the floor, right, he's decelerating. But before he left the floor, actually he was accelerating. That was part one. They already told you. That's why I calculate the acceleration. So the question that is not wrong, right? How much force does he need to accelerate? Okay. I follow Yota's question, right? That your answer. Just what do you say? The thrust must be more than the weight, right? So this is the thrust is provided by what? Normal reaction, yes. And then this is the weight. So that you can accelerate. Because part one already tell us A is greater than 0. You get it? In answering this question, you refer to the left behind to lead you to. Right now, do you know what is the normal reaction force then? Actually, you know. Your second law, part one, second law. Wait, I want to slow down here first. You need to capture this learning here. Part one, this chin. Yeah, I know that the time is going to the bell is going to ring 11:20, right? Ginny, what is the resultant force that's calculated on part one? It's in the answer, right? Is it yours 180 Newton? Yes, right? It's 180 Newton, right? No, but not how to get that 180 Newton onto the normal reaction force. Yes, this one is 600 Newton, and then it will be 180 plus 600, right? Yeah. Is it right? Because you 180 plus 600 minus 600, you get 180. So that's how I get. But this is the force acting on the man, right? But the question was asking on the floor. Oh. Second law, right? which law tells you that the floor also experience? Wow, okay. Well, now you know. Okay, we do use a free body diagram, also, free body diagram. That this is the third law of force. Third law of force, 180 plus 600. Right or not? So I'm going to change the color. Hey, where's my mouse? Yeah, I cannot get my mouse out. Okay, fine. This one for this force. Okay, this force is called the force of the man on the ground. The normal reaction force here is called the force on the ground on the man. You still remember how we use our convention for the third law? This is the third law pair. Okay, I write here force of the man on the ground and force of the ground on the man, right, is a third law pair. I write it here so that Che Xiang can see. You see, Che Xiang? Okay, was it clear? Alright, So, in the class here, you all clear or which not clear? I need to repeat. We started from the second law that we know. Right? Second law that we know. Your thinking must be very fast because it's 1 mark, right? Within 1.5 minutes, you come out with this conclusion. Then you write in very succinctly. So after being done the analysis like this, then you know, oh, this is the greater force, right? Now how do you phrase it? I want someone who has a very good English, right? Yeah. Take, I will eat over maybe 5 minutes. Summarize this thing in 1 line or 3 lines. Yeah, I want to see how many lines that they give. 1 line only. Yes. Li Wenjie can talk on the come stand up and tell the class so that we'll end the lesson. Yeah. Try. It's alright. This is more than 1 line. Okay, I know that you can explain. This is more than 1 line. How to summarize in 1 line? 1 line. Yeah. Okay. For the sake, I summarize here. This is more than 1 line also. Okay. So you cannot sabo like that. Okay, fine. To accelerate off the ground, that the force exerted by the ground on the man is need to be greater. You use the number. Yeah. And then Newton's third law, you need to know the Newton's third law that the force exerted by the man on the ground, it has to be greater, therefore the pressure is greater. Then you go back to the previous notes that yeah. Okay. This one tells me 780. This one tell me also 780. They are equal actually. There is a sentence in the middle, maybe I have to insert. These two forces are equal and opposite. Therefore, there is a larger force downwards acting. Sorry? No, because of the acceleration because of the force exerted by him by leaping. Yeah. I know that's the moment your copy answer, right? Alright, Che Xiang, I'm going to sign off. Are you there?